So, good evening, everyone. Welcome to day two session of getting started with the basics of men. And so, let's start the session then. Okay. So, before we jump into today's session, let's quickly recap what we did yesterday. So, it will be very refreshing, like we can refresh our memory. Okay. So, let's start. Yesterday, we started with the very basics, right? Like, what is exactly machine learning? I said about traditional programming. I said that we know the rule. If we know the rules, and we calculate from that rules, we calculate the answer from that rules, and that is the traditional programming. And in machine learning, it's the other way around. We already know the answers, and from those answers, the computer tries to learn the rules, right? That's what is machine learning, and that's what makes machine learning powerful. So, and I also said the definition of machine learning by Arthur Samuel, that a field of study that gives computer the ability to learn without being explicitly programmed. So that so that is nothing but there is no need to program anything, because machine learning will classify, like will identify the patterns. Like it does classification, it does regression, as I said before. So it will identify the patterns to classify something, the mail example, a spam mail example. So from the given data, and it can understand very clearly. Okay. And uh, and then we saw a nice subset, right? We saw this subset of artificial intelligence, machine learning, and deep learning, right? So AI is a very broader field. Like it teaches the machines, like it the AI, it acts as a machine. It acts as a human. The machine acts as a human. It tries to mimics like a human. And machine learning is a subset of AI, where the machine learns patterns from data. And then we have deep learning. Deep learning is a subset of ML, where there are neurons and neural networks. As I said yesterday, these neurons and neural networks are inspired from human brain, and they are used to learn very complex patterns, like, or from a very huge amounts of data. So deep learning is used when we need to find some complex patterns from huge amounts of data. And we also saw some real world examples like email spam detection. We also saw Netflix movie recommendations, and then we have self-driving cars, then face recognition, chatbots, etc. We also discussed these kind of examples. And so next, we also discussed about why do we need ML, because ML, it is really tough for our humans, right? Like to do huge amounts of data, to do huge amount, to recognize huge amount of patterns and all. But ML, it can learn from its experience. It uses its past experience, past learning experience, and it can uh, do the process. And also, it can adapt to change quickly. Yes or no? Yeah. And next, we it can find hidden patterns that humans miss. Like we humans, we cannot see all kind of patterns, right? There might be some small patterns or features that ML can also recognize. The machines, the systems can also recognize these kind of patterns, and of course they can work at superhuman speed. And then we have the machine learning workflow. We learned about this workflow also yesterday. There are 5 steps. The first one is problem definition, where we where it is a very important step, where we need to have clarity on what we are trying to solve. We need to have clarity on what kind of problem we are trying to solve. And then the next one is data collection and cleaning. In data collection and cleaning, we did what we need to collect the correct amount of data related to our problem statement, and we also need to clean. As I said, there are null values, duplicate values. I discussed some examples yesterday, right? Based on that, we need to clean our data. And then the third step is training the model. You have to train the model based on the like relevant ML algorithm. And then for the fourth step, we have to evaluate the model. We'll discuss all these things about the training and model evaluation related to classification. Today we are going to deal about classification, so we are going to discuss about those. And then finally we can deploy the model, and we should monitor our model so that it can adapt to new changes also. So this is the ML workflow. And then next, we discussed about types of machine learning. There are three basic types, main types: supervised learning, unsupervised, and reinforcement. Here in supervised, we train the model based on label data. Okay, we train the model based on label data. And here there are two types of problems, as I said, classification and regression. And today we are dealing with classification. And like, yeah, I think you remember the examples, right? For classification, it might be a spam email or not spam email. This is one of the example. And for regression, weather prediction, the temperature prediction is one example. And for unsupervised, we give only unlabeled data. Like unlabeled data, there is only input, we don't know what is the output for that. uh, like the example we give for the training data. And here the model will try to find patterns, and it will just group the similar ones. They doesn't have a name, it will just clusters. They group them into clusters. Okay, that is unsupervised learning. And then we have reinforcement learning, where the agent, there is an agent, and that agent interacts with the environment. Like it interacts, it learns on its own. If it gets positive experience, that is reward. If it's a negative experience, it gets penalties. And based on the rewards, it will try to find out, it needs the maximum reward. So based on that, it will find some best strategies to maximize its rewards. So that is reinforcement learning. Okay. And then we discussed about numpy and pandas. Here these are the basic frame, like, libraries that are required for dealing with machine learning. So numpy, it is for arrays. It is very fast, it is super efficient for doing mathematical operations. And then we have pandas. Here pandas, we can deal with tabular data. I think you can understand the difference, right? Numpy is for arrays, and it is like it can be useful for efficient math operations, and pandas is for tabular data, maybe like excel sheets, the rows and columns, right? So there are so many functions also. I think we did very few yesterday. uh, uh, at last we did some hands on, right? Few functions, we dealt with few functions like head, and we even did, I think, sort also, right? So those are the things that are there in pandas. So to keep it simple, numpy is for the math, and pandas is for dealing with data. So I think this is what we discussed yesterday, right? We discussed about the basics, and I gave you a small introduction to machine learning. So now today we are going to discuss one a very important type of machine learning problem, that is classification. I think all of you are ready to start today's session. Please put yes in the chat box very fast. If you're ready, put yes. Okay, so let us start the session. So as I said, today we are focusing on classification. Classification is what type? It is supervised machine learning, right? It is supervised learning, uh, type of problem, of machine learning problem. So let's start simple. Okay, let's start simple. What is classification? Simply, classification means predicting categories or labels from data. Like, when we take something and we are finding its own group, we are finding its type. we are finding which category it belongs to. That is classification. So let me give you an example you'll all enjoy. I think if you have read Harry Potter, or like if you watch if you have watched Harry Potter, then you can get this reference right. Remember, the sorting hat. There is that the one in Harry Potter. What does it do? It looks at the qualities of the student, and then it decides whether that student belongs to Gryffindor or Slytherin or Huffle, Hufflepuff or Ravenclaw or something. So it understands, right? The sorting hat, what it does it do? It classifies the student. This is one of the good examples of classification I can give. See here, the input is the student and the output is what house they belong to. The categories are like houses. These are the categories. The Gryffindor, Slytherin, all these are categories. So I think if you don't get this reference, I'll tell you another one. Look at this one. Organizing clothes. I think all of you will. We all separate the clothes, right? We'll put pants in one shelf, shirts go in one shelf, and then jackets in one shelf. We will segregate like this, such that if we want to find something, we can find it easily. If we want to find a particular cloth, we can find it easily. Yes or no? So that's why classification is important. Like, I think now you might understand, right? Why is classification such a big deal? Why is it such an important thing? Okay, see, classification helps us make decisions automatically. It will save huge amount of time, and it will help us catch patterns. Obviously, the what kind of patterns humans might miss, it can even deal with those kind of patterns. So classification is one of the most widely used techniques in machine learning. Okay, and now let us look at some real life examples also, so that you will understand clearly. Okay, this I think this diagram I said it yesterday, right? I think you understood this one. See, this is label data. We are giving label data to a classification problem, and when we give a new fresh input, here we are giving one bee and one honey. So based on the previous ones, like based on the previous examples, bee, honey, we already labeled them, right? Based on these labels, it will find the patterns from the new input and it will give the output. Okay, this is bee, so we got a bee. This is honey, and we got honey. Okay, okay. Now let us look at some real world examples. Okay, so you can easily understand the significance of classification. So the first example we is spam detection. I think I said this multiple times yesterday, and I said this today also. So how does Gmail do this? Like, Gmail does classify, right? It uses spam. There will be a spam section, and the spam mails will be there. So it uses classification technique. So here the input is an email text, and the output classes are spam or not spam. So the system will use the past data. It will use the past examples which we give, and it will obviously, as I said it is yesterday, it will recognize the patterns like click now or click here, some suspicious links, and based on that, it will classify which is spam and which is not spam. And the next one we have here is another great example. This one is sentiment analysis. Sentiment analysis is positive and negative, whether the given input, maybe text, not just any run, like any text, whether it is positive or negative. Like, for suppose there is Book My Show or even Amazon or something, where customers leave reviews, right? So based on the reviews, we can classify them as positive review or a negative review. For suppose if there is a movie and the reviews are like, okay, the movie was amazing. Okay, then it will understand, okay, patterns like amazing, good, those kind of things come under positive reviews. And if somebody keeps, okay, the CGI is very worst, the music is worst, something like these, then it will understand, okay, the worst, something like those as negative reviews. It will see the pattern, it will recognize those patterns, and then based on that, it will give whether the review is positive or negative. So this is sentiment analysis. Like, telling something is positive or negative is sentiment analysis. Okay, and like the next one is disease diagnosis. So doctors, they can see the patient's symptoms or like those, and say whether whether they have a disease or not, right? So machine learning can also use the same approach. It will see the patient's symptoms, or maybe if there are any tests also, maybe like scans or some scan reports or something, it can see those kind of input, and then it can classify it. Here it can classify it whether the person has some disease, or he's healthy, or like he's healthy or unhealthy, so and so person. So actually this can, I mean, this will not replace the doctors, will not replace the doctors, but it can help the doctors, right? It can help the doctors so that they can quickly analyze, and they can quickly analyze, and they can maybe spot some patterns also. It can be very beneficial for medical department. And then one more we have is image recognition. So image recognition, if you put some image, maybe an image of an animal, it can recognize whether it is a cat or dog or bird. Like it might see, okay, if it is bird, then there are some wings, it will understand that pattern, and cat may have whiskers. So based on these kind of patterns, it can understand which animal is that. And we have another example also, language identification. For suppose, if I give hello, how are you all, then it is English. And if I give something like bonjour, como ça va, something, this is French actually, so it can recognize French. So actually this kind of classification requires a huge, very huge amount of data, because we know how big our language is. So it is very, very huge, and it is very, very complex. So for this kind of classification is very complex. And this is an application of Google Translate. Actually, Google Translate, right, you can translate between the languages. So in that way this is helpful. And we have the last one more example, weather type prediction. Based on some conditions like sky conditions or humidity or some temperature, we can understand what is the weather type. Like not just the not just the temperature. I mean that is different. Yesterday I said one example where we can predict the temperature. There you're predicting the values, continuous values. There might be 32 degrees, 32.5, or 34, 36. Those are values, that is different. Here that is regression. As I said, you're predicting some value, that is regression. Here you're predicting a category. Maybe it is sunny or rainy or cloudy. You're predicting a category, right? That is weather type prediction. This is a classification example. So here you can give some like all those sky conditions and all, and you'll get the output whether it is sunny, rainy, or cloudy. So if you notice carefully, if you notice properly, like no matter what the example is, like email or reviews or whatever, the input data is similar. Like it is something like a measurable property, like something measurable, right? Like maybe height or color or something. And the output is a category, spam or not spam, positive or negative, cat or dog, so on, whether they have disease or they're healthy. So if you notice properly, input data is something like a measurable one, and output is a category. So that's what is classification. Like if you give this particular input, it will understand what category it belongs to. And then okay, now we'll go to an important topic. Classification has different types. It is there are mainly three types of classification. So there are three types: binary classification, multi-class classification, and multi-label classification. Okay, so we'll understand each one clearly. So the first type of classification is binary classification. So in this binary classification, data can be classified into two categories. See, binary means two. I think you guys all know this. Binary means two. So in this type of classification, the system can classify the data only into two categories. What we did yesterday: spam or not spam. Yes or no, spam or not spam. And even yes or no questions are also like binary classification. And then maybe like if you see, um, If you give a picture of a fruit and you say, oh, you may ask apple or not apple, something like these are also binary classification examples. So if you carefully understand, there are only two possibilities. Like, there is no other option, there is no third option. There are just two categories, there are just two possibilities we have. So this is binary classification. This is the very simplest form of classification, and it is very popular. Like, it is very used very much. Like, what, spam email, not spam email also. Then even the phones one also. Like, the phone, when you lock your phone with biometrics, it will just detect whether it is your face or not. Like, if the face matches or doesn't matches, it will not recognize, okay, this is you, and this is your friend, or this is your parent, or like your mother or someone. It cannot recognize the faces. It will just keep in mind that whether this face matches or not. That's it. So this is also binary classification. So binary means only two categories. And then we have multi-class classification. Okay, so in multi-class classification, we'll classify the data. The data will be classified into more than two categories, more than two categories, but each item belongs to only one. Okay, uh, here there are more than two categories, like not just yes or no. Maybe we have more than like three or more categories. Okay, and but each item belongs to one category. See, why I'm stressing this is because you can get confused with this one and the next coming type of classification. See, you have to get clarity on this. Like for suppose, there is, I'll tell you an example. Here we have multiple classes, more than two classes, two, three or more classes. So for suppose, for the fruit example, I give some fruit and ask, is this apple or not? For the binary classification, we can ask, is this apple or not? But for now, this I'll take an example. Maybe I'll give the fruit picture and ask, okay, whether it is apple, or whether it is orange, or maybe it is banana, something like that. I'll ask like that. See now the difference. I think you can understand now. There are more than two possible classes, right? Like, but the fruit will will sorry the fruit will belong to one item only. Like, if the we give the fruit, it can only be orange, or it can only be banana. An orange cannot be banana or apple. Like, it has to be belong to only one category. That is multi-class classification. Or else, here is another example where a student, he may be in 8th class or 9th class or 10th class. They can't be in two classes at the same time, right? Yes or no, like that. So that is what is multi-class classification. There are more than two categories, but they only belong to one output. Now we have multi-label classification. See, listen to this carefully. Here also there are more classes. Okay, but here each item can belong to more than one class, more than one label. It can belong to more than one label. Like, for suppose we take a movie, that there are so many types of movie. We can take a rom-com. In rom-com, a rom-com movie belongs to both romance category and comedy category, right? Or there can be an action movie which is also a thriller movie. Yes or no? There are they it can A movie can belong to two categories, right? One, more than one category. It can belong to more than one category. Yes or no? It can belong to multiple categories. And we can take another example. Here, if we take some students and they are divided into some random categories. See, there is one student. She's a female, so she'll be belong to that category, female, and she is a badminton player. So, and also she can get more than 90. Like, she has marks more than 90%. So you can understand it. If we have different types of classes, that particular thing, particular data what we are considering, it can belong to more than one class. That is the difference. Between multi-class and multi-label. In multi-class, there are more number of classes, but each input will only belong to one category in multi-class. But in multi-label, each data can belong to more than one class. Did you guys understand this? Okay, this so is it clear for you guys? What is difference between multi-label and multi-class? Did you guys understand this? Okay, so we'll go to the next part. We'll move forward. So okay, firstly, before going to this, I want to clear. I want to say you something. So you guys might have doubt. Okay, so this is type, right? Like these are the types. Okay, are the you guys might have a doubt that are these types the same as models? Like what I said yesterday, we are developing like we are making a machine learning model, right? A model. So you guys might have a doubt that okay, these types are same as models. Actually, the answer is no. The types are different and the models are different. See, in machine learning, a model is like it's like a method or like tool. Okay, it's like that, which are like based on algorithms. Okay, see, classification is like the task. Okay, it's like the overall task. We are sorting the data into some categories. That is classification. But the type is what kind of classification, like what kind of classification problem we are dealing with. That's what the type is. Like do we want to classify into only two categories or more than two categories? That is the type. But model is the actual algorithm. Okay, model is the actual algorithm that does the work of prediction. Okay, see, like I think you guys understood. Like the type says what kind of classification we want to perform, and the model can be the algorithm. Like there are so many algorithms like decision tree and logistic regression. We can even do with neural networks also. Neural networks, they are part of deep learning, right? We can even perform with neurons also. But what classification? We can even perform classification with neurons also. So neural networks. So yeah, these are the models. So now see what kind of model. I think yesterday I said, remember when I said, when I spoke about machine learning workflow, that after training the model evaluation is very crucial step. So like the step, it is all about whether my model is correct or not, whether my model is doing a good job or not, whether the performance is better or not, is my model making any mistakes. all these are all these come under model evaluation. Okay, you're checking the model whether it is good or not. So that is a very crucial step, because we just don't want to build any random model and just leave it like that. If it doesn't work well, there is no use, right? We need to use proper model. So see, like for suppose, like if we use one type of model, there is something called decision tree. You can use that. We should understand, okay, whether this kind of model is better or this kind of model is better, because there's so many types of algorithms. We need to understand which one is better. How can we know that? If we use evaluation model evaluation metrics, there are some metrics. If we use evaluation metrics, then we can understand which type of model is better, which type of model we can use. So before I tell about all those models, so I'll tell about evaluation first, so that we can compare the models which I say now. We can compare the models, and we can understand the performance of the models, and then we can understand, like we can, when we are learning, we'll compare them. Okay, so let us see how we can evaluate them. I'll tell about the metrics. Okay. So the first one is accuracy. This is the most common type of metric. Okay. This is the most common type of metric. Accuracy, it will simply tell us, like out of all the predictions we made, I mean, sorry, the machine made, of all the predictions machine made, how many are correct. Okay, out of all the predictions, how many are correct. So if you talk conceptually, conceptually, the formula can be correct predictions by total predictions. Okay, correct predictions by total predictions. For example, let us say we predicted like, not we. Let us take a machine is there. Okay, 100 emails are there, right? 100 emails are there. Out of 100 emails, 90 emails are predicted correct. 90 were predicted correct, like which class they belong to. So the accuracy will be 90%. Okay, I think you understood what accuracy means. Like, now I'll tell about this mathematically correct formula. See, this is the formula. I think you might be I think these terms are very maybe difficult. I will explain these terms right now. See, what is positive and what is negative? First, let's get clarity on that. Positive is like the class we are interested in finding, like we care about that mostly. For suppose when you are using a spam email and non-spam email, like not detecting a spam email, so there we are caring most about spam email, right? We are like detecting spam email. Okay, like we are interested more in which is spam email, so that will be positive. And the negative will be the other class, which is nothing but not spam. So that is the positive and negative. And for this is for binary classification. For suppose for suppose there is a multi-class classification, like there are more than two classes, right? For suppose if I'm interested more, actually they'll take turns, each will take turn. For suppose we'll take that example, apple, orange and banana. Apple, first for the first time, apple will be the positive and others will be the negative, and we'll calculate the accuracy. And then orange will be the positive and the others will be the negative, and we'll calculate the accuracy. In the same way, banana also will be the positive ones, and we'll calculate the others will be the negative, and we'll calculate. And then we'll find some average kind of thing for these results, and you will get an accuracy. Okay, this is how that happens if there are more classes. So I think you can understand it, what is positive and what is negative. Positive is a type of class we are more interested in, and negative is a type of class we are not interested in. Okay, now true positives mean, see, the actual value is positive and you predicted positive. That means the number of TP will say the number of things that which are actually positive and you predicted positive. Like for suppose there is an email. So now let us think, let us think for the spam mail detection only. So there is the email. So the positive we are interested more in, which is a spam email, right? So the positive will be spam and negative will be not spam. Okay. Now, true positives. How do we find true positives? The number of emails that are spam, and the model also predicted them as spam. Okay, the number of emails that are spam, and the model also predicted them as spam. These are true positives. That's what, right? Actual positive, predicted positive. Actually, spam email, the model also predicted spam email. So that's why that the number of mails will be true positive. And true negative. True negative is when actual is negative, but when actual is negative and predicted is also negative. Okay, non-spam email. If there is a non-spam email and the model also predicted it as non-spam email, then it is true negative. The number of those emails will be true negative. Okay, and then false positive. False positive means the actual one is negative and predicted it as positive. Okay, false positive, which means negative. What we thought as negative, we thought not spam email as a negative one. So if actual, like the mail is not a spam, but the model accidentally predicted it as spam, so then those number will be false positive. The number of those emails which are not spam but detected as predicted as spam will be false positive. And for false negative is this opposite. Like the number of emails that are spam, but they are predicted as not spam. Actual positive, predicted negative. I think you guys understood all these four terms, right? True positive, true negative, false positive, and false negative. If there is any confusion, ask me. Are you guys clear with all these four terms? Okay. So if you are getting confused, you can easily remember true means it was predicted correctly. True means whether it is spam or not spam, we'll keep that aside. True, that word true means the model predicted correctly, and false means the model predicted wrongly. Okay, so you can remember in that way. And true positive means the model predicted the positive value correctly. True negative means the model predicted the negative value correctly. But false positive means the model predicted the negative value, like the negative value as positive way, and false negative means the model predicted the positive value as negative way. Okay, true means the model predicted correctly, and false means it did not predict correctly. Okay, I think you have clarity with this. Now we'll this is the accuracy formula, and then we have confusion matrix. This matrix will just show the counts. So what I explained right now, true positive, false positive, and true negative, all these things. It will the confusion matrix will have it's a matrix which contains all these numbers. Okay. Then next we have one more metric which is precision. So precision, see, out of all the predictions, out of everything the model predicted as positive, how many are actually positive? Okay, out of everything the model predicted as positive, what did the model predict as positive? How many are actually positive? See, based on the formula TP plus FP. See, you can TP is what the actual values are positive and the model predicted as positive. FP is what the actual values are negative, but the model predicted them as positive, right? So if you combine those, if you add those, you will get the total number of predictions that model predicted as positive, right? So that will be the denominator. What this is the just the ratio, right? Out of how many, like the model predicted as positive, how many are actually positive? So the below the denominator will be TP plus FP, and in the numerator you will have TP. TP is how like the correct predictions. So that is precision. Okay. Like if for suppose you can see emails that are marked as spam, which are actually spam, like how many are actually spam, that you can understand it, right, from precision. And then there is recall. Then there is recall. Here, out of everything that are positive, that are actually positive, how many are predicted as positive? In precision, we are seeing how many the model predicted as positive, but in recall, we are seeing how many are actually positive. So in recall, out of everything that is actually positive, we are finding how many are predicted as positive. So, like out of all the emails that are spam, that are actually spam, how many the model will successfully detected as spam? That is recall. And in precision, out of all the emails that model predicted as spam, how many are actually spam? Okay, this is the difference between precision and recall. If you see the recall formula also, TP plus FN. TP means what? The actual value is positive. and it is also predicted positive. Fn is the actual value is positive, but it is predicted as negative. So you will find that is the total number of actual positives. Okay, that is the total number of actual positives, and above we'll write true positives, which means which are they are positive and they are also predicted as positive. Okay, so this is precision and recall. Uh, and the next we have F1 score. Okay, so this is just calculated. It combines both the precision and recall into one. This is the formula: two into precision into recall by precision plus recall. Okay, so it is used so that we can balance both of them. So we can use the F1 score. So it is like it this F1 score will be useful when the data is like imbalanced. Okay, I think you have clarity on these metrics. If you guys have any doubt about these metrics, please post them in the chat box. Okay, if you don't have any doubts, we'll continue. There is a small example. I'll just tell this example fast. See, you have 20 emails, and out of these, 9 are actually spam and 11 are not spam. So that's why, okay, we'll keep that aside. 9 are actually spam and 11 are not spam. So, true positives. True positive here is 7. Okay, that this box is confusion matrix. Okay, the true positives here is 7. True positive 7 means out of 9 spam emails, the model correctly detected 7 as spam. Okay, true positive 7 means out of 9 spam emails, it detected correctly as 7. And false negative. What is false negative? They're actually positive, but they're detected as negative. So, how many are left out now? 9 minus 7. 2, right? So, that is below here 7, 2. Okay, that is false negative. And now we have true negatives. True negatives are out of the 11 spam emails, how many the model correctly detected? Means not spam emails are 11. Not spam emails are 11. So 8, it detected 8 not spam emails correctly. Okay, it detected 8 non spam emails correctly. So the true negatives will be 8. The true negatives will be 8. And the other 3 not spam emails are accidentally detected as spam. So they will be false positives. So this is how it will be there. And these are just the calculations. So I think there is no need to explain this. These are done with the help of the formulas. So accuracy is calculated like this, precision is calculated like this, recall, and then we have F1 score. You just put those values in the formulas and then you calculate. Okay, now we'll move to the next one. So yes, why we need other metrics? Sorry, why we need other metrics when we just have accuracy? Like, isn't that enough? See, not always, because accuracy alone can be misleading. Like for suppose some of our data is not that great. It's okayish data. Like for suppose we have this data, we have 100 emails, and 95 of them are not spam and 5 are only spam. Okay, so when you're detecting that, I mean, or maybe just you can take some kind of thing. So 5 are spam. So it will only take these 5 emails and it will form some pattern. This cannot be that much accurate, right? But when you're detecting like not spam emails, it can be 95%. Yes or no? Because 95% of the emails are not spam and 5% are spam. And if the model just says not spam for every single email, then the accuracy will be 95%. But even though it is 95%, it's not that great model, because our training data is not that great. So it will affect our model, right? It will affect our model. So that's why we need other metrics like precision, recall, F1 score. These kind of metrics, they'll help us to understand, the strengths of that, like the weakness. Because we're calculating for like the for actual positive, how many are actual positive we are predicting, like we're predicting for precision and recall. So it will be more detailed. Okay, it will be more detailed for knowing the accurate, the model performance. Okay, now I'll tell you some two important terms. Okay, so overfitting and underfitting. Okay, overfitting and underfitting. Overfitting is something when it happens when the model learns the training data too well. Okay, training data is what the input we give. I think you can understand it. Training data and testing data. Testing data is when after the model is done, we'll give the test data during evaluation. I think I said this point yesterday, but maybe not that clearly. Training data is when you give the data when in the training process. When you give some data to the model, that is training data. And testing data is when you give after the model is done, you give the test data so that you can understand how the predictions are there, like for, and you can use these metrics for that. Okay, that is what is that. And in training data, when overfitting happens when the model learns the training data like very well, like it just remembers. Even there are some things like outliers and noise. Outliers are like the extremes. For suppose, if you take a class, like if there are like you take class marks of your class, and there are like 50 students, and like 48 students, all of them scored in 80 to 90 range, and one of the student might score at 100. Okay, one of the might student might score 100, and one probably failed. Like the rest of the 48 students are all there in between 80 to 90 range. So because the 100 is to one extreme, and the failure maybe got like some 30 marks. So there are two extremes, right? All the other data is in between, but these two are under extremes. So these kind of data is what is outliers. Okay, so these kind of things also the model will remember. Actually, it will affect a lot. It will affect, if you take the average of these things, it will affect a lot. So these kind of things must actually be removed when we are cleaning the data. When we are doing cleaning, data cleaning, we need to remove these kind of things like the outliers and all. So but if you're training the data too well, like the model learns the training data too well, it will also learn these kind of things. So it will perform very well on the training data. But if you give some random input from the training data, it can perform. But if you give some new data, the data it will not the data it did not see at all, it will perform poorly. It's just simply like this process. I mean, not process, like this type of problem will occur when the model learns the training data too well. Like training data, it just by hearts the training data. It's simply like a student, who memorizes the textbook like word to word, sentence to sentence. Like they fail to understand what the concept is, and they just remember the textbook. It's like those kind of students, that's what is overfitting. That's what is like overfitting. Okay, and underfitting is the opposite one. That's the next one. Underfitting is the opposite one. When the model is too simple, like very simple, it doesn't even learn, the patterns. It will just it will not understand the patterns. It will not recognize those patterns. That is underfitting. It performs poorly on both the data sets, both the training data and even unseen data. Test data and unseen data are same. Like you're not unseen data is what when you're not using the data for the training part. See, seen data means what? Like the model knows that. How will the model know if we give the data when we are training? So that's training data. Okay, the model will already know the training data, but the test data is what new unseen data. Okay, so overfitting, it can perform well on training data, but it will not perform well on test data. But in underfitting, it will fail in both. It will not perform well in training data, and it will not perform well in test data also. This uh, like this can be like a student, who did not even study anything. Like he'll just just he did not even study anything. Okay, that is that kind of student, that kind of thing. What happens, if he did not study anything, they cannot even answer some basic questions also, right? That's like underfitting. Like it will not perform well on training data and test data also. Overfitting is like the one who just like memorizes and by hearts everything, so they cannot see the patterns. Like even if we change something little slight difference also, they cannot understand it. That's what is overfitting. Like it's just by hearting, and underfitting is not learning at all. So that is the difference between overfitting and underfitting. So we must find the balance in between these two. We must make sure the model is between these two. It's not too simple or not too complex. Okay, that's what we need to make sure. That's why we need to make sure our model is not overfitting, or the model is not underfitting. Okay. Okay, see, you can understand this, right? In underfitting, look, the it is too simple, right? The model is too simple. You can understand here, it did not classify properly. Just think, we are classifying these two things, okay, the crosses and circles, and there is a line here, and you can see it just randomly put that line, right? It did not even try anything. It just put that line randomly, and you can see some circles are this side, some crosses are this side. It did not categorize them properly. And this is what is appropriate. There are few exceptional cases, obviously there will be few. You cannot make a perfect model, but here it is accurate, the appropriate one, the middle one. But overfitting, see this line, this is like some random line, that's it. It's not properly doing something. It just put it like that, right? It just put, you know like in a like it is doing it like this. I think you can see this. The one, it is trying to divide it like that properly. It is not even trying to like do something for new data. See, it just worked on the data which already have. Now if I want to put a circle, it cannot understand like where to put that circle, this side or that side. So this is what happens in overfitting. Now let us learn about some classification models. Okay. um, So these are three types of models. There are even more than these, like SVM is there. There are so many other classification models also, but we'll learn. I'll tell you about these in a basic way, and we'll do one type of model, a hands-on on one type of model. I'll tell you them also. So first, let's start with decision trees. This is very simple to understand this kind of algorithm. So these are the algorithms. These are the models. If we want to use if you want to build any classification model, we can use these things. The first one is decision tree. So in decision tree, the data is split based on questions. Okay, like it's just like a flow chart. I'll show you the example. Like it's just like a flow chart, and you can predict. You will ask the, like, it's not questions. Like you will take each feature, and it will take the next choice based on the feature. Like I'll tell you the example. So this is one simple example. I gave you a very simple example so that you can understand. So here, I first suppose I want to know what is the weather type. So it is asking here, what is what is the sky cloudy? It is asking, is the sky cloudy? And now if it says yes, the green arrow says yes and red is no. Okay, you can so I think you guys can understand, green is yes and red is no. If is the sky is green, sorry, if the sky is cloudy, then if it is yes, it will move towards the green arrow. And the next question is, how is it raining now? Okay, is it raining now? If it is raining, then it is raining. Okay, if it is raining now, it is raining. Like I'm just telling you simple example so that you can easily understand. It will actually, there will be so many complex things happening, but I am giving you a simple example so you'll understand the basic, what basic thing that happens in the decision tree. I think you can understand the term itself, decision tree. It will take decisions based on these three. So if it is raining now, it will move towards the green arrow, and you can that is the class. The yellow boxes are the classes. So it is uh, like the rainy. If we can predict the classes, we can predict the we can predict the classes rainy. Now, is it humid? Something like that. If it is humid, maybe there is thunderstorms, or if it is humid, then maybe there will be thunderstorms, or maybe if not, it will be cloudy. That will be one more case. That will be one more class. And then, if it is not cloudy, you're asking one more question. If it is hot, is it hot or not? If it is hot, you're saying okay, it is sunny, or not. If it is not hot, you're saying okay, maybe the climate is like, the weather is like cool or something like that, cool and clear. So this is how you can come to conclusion to one class. You will ask some decisions. You will take the decisions in this tree. You will take the decisions in this tree, and then you can understand. Okay, so this is about decision tree. So but here is something important. Now, as I said before, we'll discuss the performances also. If the tree should be built by us, and if if it is too small, the depth is too small, if it is very shallow tree, I mean, there are only few splits, then it will miss important details. Right now, I gave you a very small example, right? A very simple example. Actually, this is very simple, and this model is not that reliable when you want to predict weather. You have to use some more features. You have to understand some more features also to conclude to some kind of class. So if something is very simple, if you are only concentrating on some features, and then the tree will be very small, like the depth will be very small, and the tree will be very shallow, so it will miss some important splits, I mean important decisions. It can't capture all patterns. So that's then what happens if it can't capture all patterns, if it doesn't learn properly, it will be underfitting. Okay, it will be underfitting. And if the tree is too large, like too large, you took all the conditions, you for like every small condition also, if you checked all conditions, then the model memorizes everything. The model memorizes training data. So then it will become overfitting. Yes, right? It will become overfitting. So we need to carefully make sure that we are not making a model underfitting or overfitting. We are not causing that kind of problem. So this is what is the basic idea of decision trees. This is one of the classification model, classification algorithm for for this model decision tree. And now we have one more, logistic regression. Okay, so I think don't get confused by the name, because it says regression, and then I said yesterday regression is something like it predicts the value, and now why are we discussing about regression? Actually, this logistic regression, it is termed like this, but it is used for classification. It is used for binary classification. Okay, it is useful for binary classification, because it actually gives values only. It will give because it will give values only, but based on those values we are predicting the class. Like, it is useful for binary classification. So 0 or 1 means this logistic regression will give you 0 to 1 values between 0 to 1, because it gives probability, and probability is obviously between 0 to 1. So these 0 to 1 values will be there. For this, we are using a function called sigmoid function. I think for this we will use this so that we can map the input to a probability between 0 to 1. So logistic regression will give you values between 0 to 1. And based on this, if the probability, obviously probability lies between 0 to 1, if the probability is greater than or like equal to 0.5, then it will predict class 1. It will predict class 1. If the probability is less than 0.5, then the model will predict class 0. Okay, class 1 means, see, as I said, we'll use this only for binary classification. Binary classification has only two types, right? Two classes. So the model will predict class 1 if it is greater than or equal to 0.5. The probability is greater than or equal to 0.5, and the probability is less than 0.5, then the model will predict class 0. Okay, so for this example also we can use spam and not spam. And if the models says no, if it is like 0.8, then maybe it is greater than 0.5, right? So it will be spam. And if probability is like 0.3, then 0.5 is sorry 0.3 is less than 0.5, so it can be like not spam. I'll tell you actually a nice example. See, there is this popular example, where mice or like mouse is there, right? Mice weights will be calculated, and based on those weights, we'll tell whether this is obese or not. Whether the rat or the mice is obese or not. So you can see this is the sigmoid curve. Like the graph here we see is a sigmoid curve. So all the see, this is the probability, like this increases. So if it is below 0.5, then we can say the mice is not obese. All the orange dots, we can conclude them as the mice are not obese, and all the yellow dots we can conclude them they are obese, because see, you can see in the graph, as the weight increases, the weight is increasing, right? So you can conclude them, right? So that's how logistic regression works. Here also we have this. See, if there are too many, like if there are very few features, then obviously the model cannot capture enough patterns, because when you are finding the probability, you should include some good number of features. Okay, if not, if there are very few features, then model may not capture enough patterns, and obviously it will lead to underfitting. And then we have, if we put irrelevant features, or like features that are not necessary. For suppose I'm like for this mice example, if I keep the maybe the color of the mice or something like that, it doesn't make any sense, right? To tell whether the mice is obese or not. So you have to keep relevant features. You need to put weight for that, like for that prediction. So if there are irrelevant features, then it will lead to overfitting. Okay, that's and also the threshold can be adjusted, like the 0.5 or something. They can be adjusted based on the like the values, precisions and recalls, so that like depending on the problem we can adjust the threshold also. Okay, so that's what is about logistic regression. It is very simple. You just based on probabilities, you based on the probability values, classify it, whether it is zero, or if it is zero, the probability is near to the zero, like 0.5 less, you will predict it as 1 class, and if it is above 0.5 to 1, you will predict it as 1 class. This is logistic regression. And in decision tree, you are using a tree and you're splitting the class. So this is about logistic regression, and that is decision tree. And we'll discuss one more model, and then we'll do hands-on. So this is k nearest neighbors. Okay, KNN means k nearest neighbors. K is an variable. Okay, k is an variable. So this is also very simple. You can understand it very simply. So it's like you are obviously you are giving a new item, and we need to find which group it belongs to. So instead of asking the questions or seeing the features or whatever it is, it doesn't care about all those. It will just see, like it will plot like on a graph, and it will just see which item is closest to the data set. Like for suppose, uh, I'll show you the diagram. You can see here, right? So based on the properties and all, see the bees and honey are like this. Now there is a new point. The yellow dot is a new point. Now k, as I said, k is a variable. uh, it is a variable, and we'll give some value to it. Like see in the picture, and now like in the picture you can see there is that yellow dot, and the value is 5. So we have to consider the 5 nearest neighbors. Okay, KNN, the nearest neighbor. NN means nearest neighbor, right? the five nearest neighbors, like you will just calculate the distances between them, and you will find the five ones. See, in this picture, out of those five, there are like two bees and three are honey. You can say I drew a line also from yellow dot to the other ones. See, other classes. These are classes. Like we have one bee class and one honey class. So as you can see, the yellow dot, we drew five lines, and out of these, two are bees and three are honey. So now, which are majority? Which is majority? Honey, right? Honey is majority. There are three honeys and only two bees. So it will predict the yellow dot as B. Okay, like there is nothing else it does. It just look at the closest items it has in the data, like in the data which we give. It will just look at the closest ones, and based on that, it will predict. Okay, and based on that, it will predict like which class it belongs to. So out of these five things we have around that yellow dot, two are bees and three are honey. So that's why it predicted honey. And because of this, like it doesn't follow any kind of pattern. It just sees the distance and bond. This is KNN is also called as a lazy learner. So it just doesn't train anything. So it just remembers everything. Like it just remembers everything. But what happens, the performance, as I said before about overfitting and underfitting, like overfitting means it remembers everything, but here it happens in other terms. See, if the k value is very small, like if it is very small, then there is a chance of overfitting. Okay, it will the performance actually depends on k value. So if k is very small, like it is one or something, it is super sensitive then, and it is very sensitive, and even the outliers can be used for the prediction, which causes overfitting. And if it is very large, if k is very large, then it has to deal with so many things, so many classes around it, its neighbors, and it will be like very difficult. So it ignores like the important differences and just predicts the majority of them. So a right k value must also be there for knn. So I think you guys understood these three models, right? What is decision tree, logistic regression, and KNN? These are some basic classification models. So I just said, since all of you are beginners, I said you in a simple way. Okay, I think you guys understood these three models. Do you have any doubts? Okay, do you have any doubts? Or all these three models are you have clarity on these three models, right? Okay, how k value is evaluated? Like, see, there is no particular k value for like for a thing. Like it depends on the problem. Like as I said, of course, small k value means it can lead to, like it can lead to overfitting, and if it is large value, it can lead to underfitting. See, there are some methods, like there are some tuning methods also. There are like cross validation and all. I mean, I think since this is for beginners, I think you might like feel a little difficult to understand, but I think you can use these methods, like cross validation will be there. Like cross validation, it's like, I mean, the training data will be divided into some groups, like they are called folds. Okay, this is cross validation method. I'm just telling you in a simple way so that you can understand. So based on this fold, it will train on each fold for some time, and for the k, like it will pick the k, like it for each group of training data, these folds for each fold, I think like it will calculate the accuracies and all, it will calculate the metrics, and based on the metrics which has like the good highest accuracy or the errors are low, like this it can calculate the k value. There are some methods like this. Okay, I think it will be a little difficult. Yeah, you can select the k optimally also based on these methods. You can use things like this. Is it clear? This is cross validation method. You can use this method actually to get a nice value, like I mean good k value. There's still other methods also. If Rani, whether is it clear? Okay. I'll actually give you some roadmaps, like some other good resources at the end of the boot camp, so that you can understand clearly. This is a very short boot camp, so it's like a boot camp where we can introduce machine learning to the beginners. So I cannot deal everything. Like I cannot say everything about like in a detailed way. I'm introducing you such that you can get a basic understanding of what machine learning is. Okay, I'll give you good resources also at the end of the bootcamp so you can understand well. So I think now let us start the hands-on. Okay, we'll just do a small classification model. In the meanwhile, attendance forms will be there in the chat box. Please fill those forms. Please fill those forms, and I think you guys know it. Open Google Colab. You can just go into the Chrome and search for Google Colab and open a new notebook. I'll tell you how we can make a simple hands-on, like simple classification model. Please fill the attendance form. Don't forget. Okay, I think let us start the hands-on. So did all of you open the Google Colab? Okay, let us start. So first, let us import the necessary libraries we have. Uh, First, let us import NumPy. Obviously, yesterday I said about NumPy, right? Uh, we are using NumPy for computing. We are using NumPy for computing, and then we'll import also this one. So now there is this like we are importing this from sklearn. Sklearn is like it's scikit-learn. It's a module. Okay, like it's a module which has it's, it has some modules like data sets or like model selections like this. So wait a minute, I'll just Okay. So we'll import the data set now. So there is this data set called iris data, which has a flowers. Okay, it has flowers related data set. So it has like based on the flower length, like the petal length, petal width, petals, right, the flowers have petals. So based on those, the flowers are classified. Like there are some flowers, they are classified. I'll show you that also. 1 minute. So for that, we have to, what we have to do is, after you have to import this. When you import this, what happens is that, see, this dot data set, this module data set module have some default data sets in them. So there are like some load, there is load iris, this has iris related data set. Iris related data set is of flowers. And then there is house predicting data set. There's so many other data sets also. We'll know them one by one. So today we are using iris dataset because we want to classify, right? For we want to classify in this, there are some flowers. Okay, so based on that we'll classify. I'll show you it. I'll show you how this data is there. uh, after you load this, you can load like this. You load the data set into this. Should I zoom a little? Okay, after loading this, uh, now you can create a data frame. Yesterday we dealt with data frames, right? One minute. Okay, put an S here in the data sets. Okay, after this, you will create a data frame. Yesterday we have learned about data sets, right? Okay, for that we have to import actually pandas. And after that, after creating a data frame, a variable, we have to create a data frame. We can convert this one we have to a data frame. Okay, you can just put iris. Right, iris is this one, this variable name, right? So you have to put this here, iris.data. It will collect the data, and then for columns, since yesterday we had default columns, right? 0, 1, 2, like that. Here we can put the feature names. Feature names are nothing but the labels, like the feature names are like label names, the target names, what the output is. So next you will put iris underscore df. We created the data frame, right? Target, this is what yesterday I said, right? This is the column name, how we are accessing the column name. So we'll put this here, iris.target. We're giving all the target values. This part will have all the target values, I mean the labels, the flower names, and these will be stored in this column. Okay, so then you will print. Yesterday I said, okay, wait, we'll print it. Yesterday I said about how we can print, the first 5 rows, right? We can use head function. So we will use the head function and see. So we are just putting this in. They're like these are zeros because like the values are zero. These are class numbers. This is the sepal length, sepal width, petal width. These four are like the characteristics. These four are the characteristics of a flower, and this is the target. This is the flower. The numbers like there are class 0, class 1, class 2, like that. We Zero is one type of flower. Okay, so this is how the data set will be there. Now we'll do the coding fast. Okay, so after this you even need to learn import this module. Model underscore selection, import train test split. Okay, so see what happens here is this import, the one we did before, this load iris, this will have all the data. It will have a huge amount of data, flower related data. We are using this train test split. We are importing this such that we can divide our data into train data and test data. I said the significance of test data before. We have to check whether our model is properly working on unseen data or not. So we have to have some data set and test data set. So for this, we have to split the test data which we have only. Like we have some data, we have to split that data only. So for that, we are using this train test split. And at last, now we have to yes, we have to import what classifier we want. Import k neighbors. We'll do knn classification. So for that classification, we need to import this classifier. Okay. There is no u actually. So after this, now you have to load the data which you already did, and now we'll find x value. We'll find the x-axis. Like we'll divide the x. We'll take the first two features, and like the sepal width and sepal length and sepal width. And we'll actually divide this is for used for indexing, as I said before. This is used for indexing. We are only taking two features, sepal length and sepal width. We are only taking the first two features from the data set. We're only considering those two features. Okay, and then we there are so many flower types actually, but let us deal with like binary classification. So iris dot target, as I said, the target values are what they are. They are the flower names, right? So let us deal with binary class. So for that, we can just take like this. Okay, I think. Uh, so this is used to make it as a binary class. Okay, this is used for a binary class. Like okay, okay. Now the next step, we have to classify, like take some k value. For that, first we'll split the data set. We have to split the data set. Let's take x underscore train, which is training data set. X is the features. X are the features, right? The features which are sepal length and sepal width. Then you take another x underscore test. You're taking dividing this into test set. And then there is y underscore train and y underscore test. Now we did import this, right? Train test split. We are using this. So what are we splitting? We are splitting this x and this y, right? So that's why you have to put here x and y. Okay, and then we'll put sorry, test underscore size. Oh no, wait a minute. Sorry, you have to put test underscore size equals to 0.2. Means 0.2 in the sense you are taking 20%. If it is 0.3, you will take 0.3 means 30%. So out of the entire like the entire data set, you are taking 20% as test set. Okay, and then this is random state, which means whenever you run the code, it will take same amount, same those 20%, those 20% data as the test set. Like, for suppose if it is taking some random, if there are 100 flowers, it will take those 20 flowers again and again. It will take those same percent of 20% of flowers as the test set. Okay, it will not change even if you run the code same times, because it is taking randomly, right? It might take some other 20% next time, but if you put this random underscore state equals to 42, then it will take the same 20% code. And then you will divide the code here. Like this. After splitting, now we will take the model. Okay, wait, I sorry, the cursor is not on. So model k neighbors, we imported this one, right? This one, exact this one. This is the function name. So that's what you have to keep here. I'll just copy paste here. This is the same one. This is the one which is here. You are just using that function. So you have to put some value. For this function, you will give the parameter the neighbors. So n underscore neighbors. As I said about the neighbors, right? Like what we did in the example, we took 5, right? We'll take 5 here also. Okay. So this is the neighbors, and now this is the last part. Like, I mean, this is the part where we train model dot fit. This is the training part. Okay, we'll now for training, what do we need to put for training? We need to put the train features and along with the train output. Okay, we need to put the train features along with the train output. We have features in which variable? We have features in this variable, right? See, we did here. We took all the features in X, and the features, some of the features we put in train, and some of the features we put in Y train. So we have to put only the only the training features, and we need to put what we need to even give the output, right? For spam emails, what did we do? We gave the mail, and we gave whether it is spam or not. For here also, we need to give X train has the features, and Y train has the output, like what kind of flower it is. Now this is what is training. So let us run this. The training will happen. uh, okay, there is no U actually. Sorry for that. Yeah, this one here also there is no U. Okay, so here the model is trained. After the model is trained, what is the next step? We need to we can do the evaluation and all. Okay, so this is what how the basic model works. I'll just wind up within 5 minutes, guys. Now let us see how this happened. Let's print the the accurate, like the metrics. So for that, we can just print let us find the accuracy. So for that, actually, okay, wait, I did not import them, right? You have to import the metrics. So sklearn, this scikit-learn also has various modules. This is metrics module. So in this, we'll import accuracy score. Accuracy score is the one. Okay, and then now what you have to do, we have to predict, right? Like we have to predict the rest of the 20% data we have here. We have to use that for testing. So we have to predict. Now we are evaluating the next step, the fourth step in the machine learning workflow. We are predicting. Okay, we are predicting and we are testing. So let us put this as y predict. Y means with the outputs, right? So we are predicting. For that, you have to just put the model. Model is what? Here we imported the model in this variable, right? The k neighbors. So we have to put model, and we have to model and predict. This, there is a default function for prediction for predict. Now what do we have to give? X test. X test. Why? X train is what the training features. X test is the output. Y train is, sorry, X train is the features and X test is the features for test. Y train is the output for the X train and Y test is the output for the X test. Yes or no? So what do we have to put here? X test. You have to put here X test. S test means the unseen data, the 20% of the data which we left for the unseen for the model, the 20, this 20% of data the model did not see at all. So that's why we are using this for testing the model, and we are storing the values with ypred. Now what we'll do, we'll compare this ypred with ytest, right? We have to compare this ypred with ytest. So wait. I put a capital X. Wait 1 minute. Sorry, guys. Really sorry. Wait. After this, we now will compare. We have to compare the accuracy, right? So for the accuracy part, you'll just print accuracy. Okay, accuracy and underscore, because we used this one, right? We imported this one. This is the function. So accuracy score. And then what we are comparing, what we have to compare, y test and y prediction, right? Y test and y prediction, we need to find the accuracy. What is the conceptual one, like what the conceptual formula I gave you, like the number of correct predictions by the total number of predictions, right? Like that you have to find accuracy, like you are finding for this particular class. So you use y underscore test comma y underscore pred. Okay, and then you can just print this. See, this is the accuracy. Okay, one, we have a good accuracy. There's sometimes actually this we had a little problem of overfitting here. We need to make sure we divided it properly. So see, now we, based on this you can understand, right? Okay, we can see these evaluation metrics and we can make sure that our model, we have to change some things from our model, and we can actually make the changes, make our model better. Okay, so this is how it happens. Um, so this is like how the process of knn happens. Okay, this is here we train the model and we did evaluation, and now based on this evaluation we can change the k values. Like for suppose if I change the k value here, as I said, k value, if I put some 7 maybe, and I'll rerun this again. Yeah, it remains same. We can actually use various other methods also. Yeah, actually it's not changing. You can change the k values, you can change the neighbors, and you can make sure. Actually we got we got one per like total accuracy, so we need to make sure, and we need to change the value such that will the model is nice and perfect. So I think that's it for today's, guys. Today we learned about classification models. We have learned about three types of models: decision tree, and we learned about logistic regression, and we learned about KNN, and we performed KNN now. So, you guys have any doubts, or is this fine? I think, is it okay for you guys? Okay, then. Uh, Thanks for joining this session for the day two. Also, do not miss to join tomorrow's session. We'll be dealing with regression tomorrow, which is the next problem of supervised learning. So, yeah, that's it, guys. Yes, if you have any doubts or else, you can send a mail to us. Yeah, that's it, guys. Thank you for joining day two session, and see you tomorrow, guys.